When did you put the formwork underneath it?
So-
Is that at night?
Yeah, the first step would be, we actually, without the forms in, we did a transverse cut. So we kind of cut it into segments, and then we'd come and we'd put the formwork right underneath it on the same night.
Because you have, what, 6 hours you said?
Yes, yeah.
One night. How long did it take to form it?
One night.
One night?
Yeah.
We go 425, we don't let in there. What about that?
Yeah, so what, there'd be days beforehand where you kind of saw in that sketch, there'd be a ledger underneath the platform, and that bottom angle would kind of, you'd be able to just kind of sit it right on there, anchor it, move on to the next one, and then we'd have a crew behind them and level up the legs, get them close. And so by doing a little bit of pre-work ahead of time, then you can get in there and really do the production work when you needed it. Anything else?
All right, guys, we'll go ahead and roll right into case study number 2. This first slide is just a little bit of a narrative of what this real scenario was that we were dealing with. We were contracted to build a new elevated station for the CTA in the Loop neighborhood downtown. So Loop is as downtown as you can get Chicago. The traffic on that part of the CTA system is congested, short headways. The new station that we're going to construct is between 2 adjacent stations. Those have been in use since 1896. Much of the structure that's supporting those, as well as the elevated structure that's in between those 2 stations, is original. So we were dealing with connections that were over 100 years old. As I mentioned, five routes operate on the Loop elevated lines. Service is to remain undisrupted during completion of this contract. The original construction of the elevated structure at this project location is not adequate to support the new station framing, and part of that's because we're between 2 adjacent. So previously, the structure at this particular location didn't need to accommodate any more than the tracks and train loads that were experienced at those locations. Completion of this contract as designed. So that includes, we were handed a structural package that had all of the new structure design, all the new foundations, columns, any other steel retrofits of the original structure are the means of the contractor. And you guys probably know what that means, but that's basically how we get from start to finish is on us to develop the procedure in order to deliver a quality product safely. The contract also delegates design and implementation of any temporary structure which is used or which is required in order to accommodate the structural rebuild. Click to the next one. So here's a picture of what we're going from and what we're going to. This is the existing columns and foundations. Everything that's hashed is going to be removed, and it's going to be replaced with the structural steel that you see over here. There's also a canopy that's going up on top of this. So the framing that's necessary to support this additional platform station house canopy is much more robust than what's there now. And again, this is, as it stands, this column, this foundation is all that's supporting the CTA operating loads through this section. So as soon as we go to demo those, we have to develop some way of supporting that in a temporary condition while we do the steel retrofit. And here, this is also just a picture to give you an idea of what tight quarters we're in. Here in the very foreground of the picture, you can see the south station that I noted was going to be demolished as part of this project. In the back of the picture, you can see the adjacent station to the north. So our new station that we're building is sitting right here in between the 2. So what we're doing is we're consolidating 2 stations into one large station that's in between. And that's also modernizing the CTA facility on this part of the loop, which is badly dated. So we brought a lot of improvement to Wabash Avenue. Another consideration that we have to take into account here is that we have voids in the subgrade throughout the project site. So everywhere here that's indicated in yellow, those are vaulted sidewalks. That means that these adjacent properties have a basement level that extends out under the sidewalk. Basically, there's no earth there to support any loads that we're putting onto them. Same thing with noted in red. Those are utility structures in the street. So those are, you have to essentially think of those as hollow spots in the road that you aren't going to be able to put load on in any sort of temporary condition. So I want to keep this one non-technical, but I do want to just kind of go through a critical thinking brainstorming activity. Once we've established a clear objective, which is kind of what I was talking about through these last few slides, is what might we be able to do in order to do these major structural modifications while maintaining continuous operation by the CTA. So once you have that as your idea, this is what we need to solve. You start with a concept development to complete your objective. Then you have to think about the impact to the project, both the direct impact, which I would say is everything that is needed to implement our temporary condition. And then what I'm calling peripheral is everything that we need to think about that's a residual impact. Because we need to think beyond this temporary structure that we're developing to hold up the tracks. We've got to think about then what else is this impacting? What is next to our project, underneath our project, that we also need to be vetting. And really, in a condition like this, as critical as this temporary condition is to support CTA structure, there are going to be a lot of eyes that are put on it, from CTA, engineers independently. So it's going to go through a lengthy review process, and there's going to be a fair amount of assurance that we won't be in a position to fail because the stakes are too high. The owner, no one's going to let that happen. But if we as young engineers or project managers or whatnot can vet these processes, vet these issues or impacts on the front end, you cut down on the number of review cycles, you cut down on time, and that's critical so that we don't lose months on the front end of a project where we're just going through this cycle of kicking it to an engineer and having to come back and say, yeah, but you didn't think about this. Also to be considered would be impacts to the neighborhood. What is it going to take? How are we going to impact those around us in order to complete this project? And then operational impacts. By that, I mean CTA operational impacts. I've already mentioned that they've told us that we need to do this without any major disruptions or without any discontinuity in service. That doesn't mean that there's not going to be any impacts. We're going to have to work during non-critical rush periods. We're going to have CTA flagmen posted. We're going to have to establish slow zones, things of that nature. But what I started by saying here, I want to keep this as non-technical as possible. And I want you to just kind of think through, and thinking back through the last couple of slides, like I mentioned with the vaulted areas, those voids, with the proximity of the neighbors to this project, what we need to do in order to support the structure in a temporary condition, and then what it means for the project, what it means for those around the project. So if you guys want to, again, pair up and start talking about some of these issues that we might run into, and then we can
from there. Sometimes I think here is this the road that goes underneath.
I'm guessing that's the roads, because that's where you get the towns and stuff like that.
No, but if you drive through parts of Chicago,
Yeah, they're one of the places.
there's a road that goes, the track's gonna go underneath.
What's it about?
Yeah, but the road it goes right underneath.
Oh, yeah. Oh, yeah. The whole thing.
So we're just talking about temporary structure. Is
I'm assuming it's. That would have been there. So you had to.
it should revolve around the impact. It's such a highly critical part of town, most times it's important. If this project is delayed, it's better to be delayed because we're trying to get away from all this thing. The fact is to deliver.
The whole thing is,
Yeah, so that, in those times, it could be something that exists.
yeah, that's.
Like there's always some section.
Something about safety, no disturbance.
So what is this support that we
Yeah, so,
Minimal
sorry,
impact. Right. Is there anything else? No, little impact on the surroundings. No effect to traffic down below.
in order to hold these up.
That's specifically regarding the trains.
Oh, okay. Yeah, so they are pretty arguing about that various time out, I would put the rest back in the same road.
Provide, build, perform the retrofit, of existing station. It is, yeah, it's a station. It's a station. It's about So are they building? Is this a station? This is a station. Well, no. This is part of this design. This is the demo. This is the design.
going directly to your.
These are sliders.
Still all crazy there, so.
I mean, technically, from the design standpoint, it's probably not a technically, it's support and then have
Yes, this is a track.
Yes.
So why is there
also, like, just like the support, like that, where the document having to put that
Yeah, I think he's got it.
So like you put them on, but you this what's that?
Oh, okay, so there's already based on
Scale.
So there's like part.
And that's why it's the main thing.
So is that the right hand?
Yeah, so the cut through that I did is kind of a section view if you're looking down the rail. Can't remember if I did right side first. So, yeah, it would be off the side.
That is what we're seeing up there?
Yes.
Right, so if you put this up right here, here's your canopy arm coming up. So that's just a section cut looking this way down.
Kyle? Oh, Hannah. Does that help? That's it.
So that cut that you have is kind of a section view looking straight down the rail. And what you have is the left side of the platform was the screenshot that I grabbed. So that's, if you were to take a slice right through this station and looking down the left side here, if that clears that up.
Clear as mud.
So what can we do?
Hey guys, just to clear something up real quick, it was pointed out that on one of those cuts, there's a note that says existing stringer to be demolished. There was a part of this project that we had to replace some track spans over a weekend. But for the purposes of this case study, I was just looking more at the column and foundation replacement. So you can disregard that note. Everything that's inside of the hashed area, meaning to the right, all of that structure remains. So, this previous picture. So to kind of give you another little view here, you have these columns on either side. There is a steel, they call it a bent girder on the CTA elevated line. This steel all was to remain. So we left that in place We stripped off the existing columns that were there, we broke out the foundations, we put in new foundations, new columns, and then built this station house out around it.
So what would be, we have name for that, safety, how do you put it? Yeah.
Yeah, I was going to
I think originally, obviously, the first class, get into it.
but I thought it was like deep,
Not this area.
Okay, that's, I thought it was red. This is like, there's nothing on like the other side of the right?
Right.
This is the way.
No, it's a one. If you go a little further, it's two.
Okay.
But no, this is one way side.
so how can you do?
So, but you guys couldn't use the sidewalk to lay down the right?
We took over the sidewalk and we put up a sidewalk shed where pedestrians out. But it was really limited as far as, you know, I can lay down there.
It was basically delivered.
We had a little bit of a laydown yard that was north of the job site, so a little bit further north, they gave us another lane where it was kind of free construction.
I just got lucky.
So those like,
How big is the impact is still between?
So like, how did you were busy and you're up on the picture, this space, this remains. This is not being correct.
So can you see that bracket? That's originally steel.
No, what is it impacting, not what the impact is.
This was replaced. That's right. Here, a good way to differentiate what's new and what's existing is that the new steel that came out is prime painted only. It's not the same red color. This is a picture a few months ago before the structure was painted to match.
Oh, okay.
So anything that's in gray is new steel, the red is existing steel. So we did have to redo the connection there, but that's original material.
You don't think?
Why are they doing that?
The bracket, so existing building, a large impact. Foot traffic is impacted as well as on the exterior.
Because I can tell you, matching up new steel to existing steel is really, really good, especially when it's steel that's old. Because they were doing riveted construction, and it was just kind of like approximate spacing. So you can't tell until you're fabricating and say you've got range typical spacing on these bolts. It was all fast. It was kind of a big deal. They made it work. Anything else on road connections? We did a lot of field fabrication.
Disregard, right, that disregard.
Because you can assume that building
This project heavily impacts foot traffic. Foot traffic. Does this have an impact on pedestrians?
Does anybody have any thoughts or considerations that they've given to how we're gonna do this steel replacement while maintaining train operation up top? Anybody? Okay.
So, you end up putting, you're gonna take out those existing columns, so do you have to put temporary columns on the other side and then bridge laterally to kind of hold it, create a basket?
Yeah, absolutely. So these are actually, we skipped to a picture where this is our temporary columns. So the columns that are removed are outside of this. This is in, you can see this is closer to the track stringers, and you can see in the back of this picture where you have one of your existing columns that's removed. So you have a temporary frame that's built up here supporting this girder that spans underneath the rail inside of each of those existing columns. Now, you can see from this picture that a big deal for this is that the way that this frame is constructed, it completely cuts off access through the job site. From that plan sheet, you can kind of see that we have a linear project here, a project that spans down the block. So in order to build this project, we had access from one gate on either end of the project. As soon as we installed one of these temporary frames to support the structure, you've now cut off your access completely to go from one end to the other. So to go along with that, the CTA didn't want us to temporarily support 3 consecutive vents anyway. We wouldn't have wanted to do that because then you put your middle structural work on an island. You have no way to get material to it, get equipment to it. So for that reason, one of the considerations that you have to make is along the length of this station, which is 400 feet long, figuring on that you have these columns that are every 50 feet, and you have one at the start point and the end point of your platform. That's nine column locations along the length of the project that you kind of have to leapfrog through and sequence and build out methodically in order to build yourself out in a way that you can continue on with the project as you clear some of these areas. Again, this is here showing where we have our temporary shoring system that was fully designed by an engineer that we brought onto the project. This was not part of the design package. We were handed a drawing that showed column removal and replacement, and we're kind of said, in the contract document said it's on you to determine how you're going to do this. A good question that I had heard was, did we have to consider that now we have a cantilever girder here? And I didn't include this in the presentation, but yes, it was a factor to be considered. This existing plate girder construction that was out there is deep enough. There weren't structural concerns with the cantilever that was there. We did have it checked where we have some of these big girders are longer than others, so you had kind of a sail that was out there. It does pick up wind load. But it was reviewed and determined that the structure was adequate to self-support in those cantilever stands. This is jumping to the new column installation. So this is showing the temporary structure has been removed. You can see where the new foundation, at least the excavation for the new foundation. I know that there were some questions as far as clarifying what was new versus what's existing steel. So this is a good indicator where the new steel came out, only prime painted. All of the existing steel had the red color coating on it. So you can tell what was new, what was existing based on that. You can see that we have a new column. We had to redo the connection angles here just as part of